Good afternoon. Welcome, everybody. We are live. So, welcome to our monthly LinkedIn Live around the Alliance. I will wait a bit for everyone to take the time to arrive, grab a coffee or a tea, and comment in the chat if you're team coffee or team tea or water. And I'm very happy that we are doing this today. Thank you everyone for tuning in. And obviously very happy that you are taking the time to spend the next hour with us. So welcome. We'll wait a little bit. But this is too awkward for me to stay alone, so I guess we'll start. I'm Julie Schnadek. I'm the Director of Community at the SDIA. And today we'll be talking about heat reuse, transforming heat into a sustainable resources. I could say that it's my favorite topic, but I'm not the expert here, and that is why I have three wonderful guests today. And hi, David. Hi, Adrian. Good afternoon. So, yes, as I was saying, extremely happy to have these three wonderful guests today with me on the panel, starting with Zoltán Andrássy, the CTO and founder of Heatventor, who is joining from Hungary. Can you please quickly introduce yourself?
Hello everyone, I'm Zoltán, CTO and co-founder of Heatventors. I'm an energy engineer and an HVAC engineer. So basically, I'm really obsessed with energy efficiency, and every connecting topic.
Thank you, Zoltán. We are also joining today with Drew Turner, the Global Marketing Manager from Danfoss Sector Integration, who is joining from Denmark from a coffee shop. So this is part of being live. We need to accommodate. So can you please introduce yourself?
Yeah, absolutely. Thank you, Julie. Drew Turner, as she said, Global Marketing Manager for Danfoss Sector Integration. I've been with the company now for 8 years, in the industry for going on 25. Traveling around Denmark right now, working with my colleague Martin sitting across from me on heat recovery and heat reuse, specifically for multiple applications, but especially focused on district energy.
Thank you so much and welcome. And last but not least, we have today Jeroen Bergs, the CEO of Block Heating, who is joining from the Netherlands.
Hi all, I'm Jeroen Bergs from Block Heating. We focus on building a CO2 optimized IT infrastructure, and that means that we take heat reuse seriously. As Julie said, we have one data center in the Netherlands at the moment.
Thank you everyone. So you all mentioned heat reuse because obviously this is why we're here today, and we will explain what is heat reuse, why heat reuse is not already the norm for data centers, and what could be potential blockers for the implementation and how to solve them. And then we also want to express to you that we have a steering group at the SDIA focusing on this topic and already working in there. And my three guests today are also participants of the steering groups. So today I'll be the moderator of today's session, and it's my job to get to the core of the topic and to trigger honest debates and opinions. And so I would like you, the audience, who is already very active. So welcome everyone. This is great that you are also sharing where you are from. Already some Netherlands, Germany, UK. This is great. Leaf Clouds, Netherlands. Yeah, very happy to have everyone here. So I would like you, the audience, to help me in this today's session, because you will be able to post your questions in the chat, and our team behind the screen will moderate the questions. Basically, what do you think? What are these solutions not being adopted? What are the concerns? What are the barriers? All the worries that people might have? And what do you believe can be done to fully adopt these solutions? So please post your questions in the chat. We want this to be as interactive as possible, and we will basically pull your questions after we will have some discussion, of course, with the three panelists, and we will pull your questions and observation on the screens, and we'll talk about them. So yeah, extremely happy to be here and to have three wonderful guests. Hi from France. I'm also from France, as you can hear. So great. We have a very nice European coverage already. So let's get started. I will throw the first question out to set the scene. Drew, how does your company contribute to the creation of a sustainable digital economy?
So Danfoss has multiple offerings specifically focused on digital economy, or especially data center applications. I'm really focused on heat recovery heat pump systems, and specifically around transitioning the data center built environment from a cooling focused to a cooling / heat recovery focused usage. The opportunity that we see is that every chiller is a heat pump and every heat pump is a chiller. It's just whether or not you're making use of the heat that's produced. And what we're working on is how do you facilitate that, both from the product side and system side, but also from the business side, which we've discovered is the most critical gap, or the most critical issue to address.
Great. Thank you for sharing this first observation. And from a business point of view, obviously, that's really interesting. What about you, Jeroen? How does your company contribute to the creation of a sustainable digital economy?
Yeah, so I already mentioned in the intro, like we're focusing really on the CO2 impact of our IT infrastructure. So one thing we do is we operate direct chip cooling, and that allows us to get higher temperatures, allows us to reduce the energy use overhead, so the PUE. And yeah, one of the main focuses as well is a heating aspect, making sure that the waste heat from the data center is used in the daily world. So we are physically located next to a greenhouse to make sure that we can easily deliver that heat.
Great. Thank you for the first observation. And what about you, Zoltan?
Basically, Heat Ventors has a thermal battery, which means that we have a thermal energy storage, and we can fit it to different systems. We target this question or this topic from two different angles. The first one is we are trying to make the cooling system more efficient, because by adding the storage, it enables optimization in time. So basically, it is possible to generate the cooling energy when it has the highest efficiency or when it's the cheapest. So usually it happens during the night, using the cooling system more when the external air temperature is lower, or using more free cooling. And another angle is the heat reuse. Basically, our technology as a storage ensures that we can connect the heat generation side and the demand side. And because there is changing profiles and changing needs in both sides, as a middle, we can basically eliminate this changing in the system. So we can ensure that the most excess or waste heat is used at the end.
Thank you. These are all great points, and we are already observing that that there are different applications, different meaning. So I would like to focus now the discussion on what does heat reuse mean to you, and I will start with Jeroen.
Yeah, so for us, heat reuse means that most of the energy that goes into the data center comes out useful. So that also means that we, for example, insulate the walls to make sure we don't leak out too much heat. Yeah, and we really also like we're having a dashboard, and energy reuse is really a key metric for us up there. So yeah, basically, um, our goal is to make sure that is used, and yeah, we have to make it work, I guess, as a data center industry.
Yeah, yeah. Obviously, we need everyone on board to make sure that we get to this topic. What about you now, Zoltan? What does heat reuse mean to you?
Well, as an energy engineer, well, I wouldn't say I made an oath, but that I need to basically design the most efficient systems. And in data centers, if we look at the normal cooling systems, if we take IT load as one, then the cooling need is one, and basically the heat generation or excess heat is two or three times more. And if we are not using that heat, that's basically a waste. So the big question is how and where we will find the place for that heat. And what I mentioned earlier, usually when we try to connect two different systems, there can be some time differences where our storage can be and can act like a flexibility increase method.
Thank you for sharing this statement as well. And Drew, what about you regarding your definition on heat reuse?
So I'll play off what both Yaron and Zoltan said. They're right on. They're spot on. But the heat reuse to me or to our company really means being able to make use of it to the scale or the level of the heat that is output on a consistent basis. In other words, making 100% use of the heat 100% of the time. And how you do that, both from the application side and from the business side, is critical. From the application side, it's critical to tie into a consistently high heat load. And the best way to do that we've discovered, which is related to why I'm here in Denmark now, is with tie into a district energy system. Another way, or another critical factor there is, if you're going to do this, how do you enable it from the business side? And just to expand on that and the comment earlier, what we've determined is most critical is to either convince the data center that it's in their interest to facilitate the heat reuse or expand their definition of their business to into providing heat or selling heat as well. Or, and this seems to be the better path potentially, to have a retrofit of an existing system with a water-to-water heat pump system that is actually owned by the district energy utility. And you keep the existing assets there that are cooling or have been cooling the data center formerly as a backup to this retrofit system. That's what it, I guess, summary of what it means to us.
Yeah, this is great to have also your perspective to the topic. I can see that we have a very active chat already, so there are some very interesting questions. And the first one is in line with what we were discussing earlier when we were preparing the session. So I would like to bring the question from Robert Tozer. Sorry. what do you think are the most important barriers to a wide implementation of heat recovery from data centers? And in order to answer that, I would like to start with Drew. I will say with your perspective to the topic.
Yeah, the biggest barrier is what I was just highlighting on, which is the ownership of the assets and who defines the business. Because the data centers are very much focused on the data center revenue, redefining the data center to be itself from a cost center to one that also produces revenue via heat sales is a tough one. You've got to have the right small scale hungry co-location customer, for example, to define their business that way. Or you work with the district utility, as I was highlighting earlier, to come in and let the data center to retrofit a 10-year-old data center whose cooling assets have become inefficient, to then retrofit it in with a water-to-water heat pump system, providing the cooling to the data center, primarily loading that first, keeping the existing assets as a backup, and recovering the heat to the district energy system. And then the cooling or the data center becomes a customer for the cooling side from the district utility.
Thank you. Jeroen, do you have perhaps additional comments that you would like to make on Drew's statement and this question also that we have from the audience?
Yeah, I think so. Like, if you look past the first thing that Drew mentioned, like you need to have the data center on board, then I think it's down to the cooling technology, like getting high enough temperatures so that it is useful at once. Like, I think the current cooling technology, like the typical air-cooled systems, I think 99% of the systems are air-cooled. I think that's a big bottleneck in really making the heat useful for other parties.
Zoltan, I would like to bring also your perspective to this question. Do you have additional feedback from Drew and Jeroen statements that you would like to add on to this?
Yes, I think availability is a very important barrier because if we look at the technological approach, then we can see that the highest heating need or the highest need for the heating is needed during the winter time. But in some locations, data centers can be run on free cooling during these periods, which means that the excess heat will have a very low temperature. And the most heat will be generated when chillers are operating or compressor-based cooling technologies are operating, which means that basically during the summer, the heat generation will be higher, but the heat demand will be lower. As we see, district heating companies are usually targeting households as end users, where during the summer only the domestic hot water generation is there, which is a much lower need compared to the heating. So that's why there is it's needed we need to focus on industry, we need to focus on applications and facilities where heating is a need as well during the summer, and it has a constant need. So that's my additional topic. We cannot help with our technology for a yearly storage, but on a daily level we can help in the optimization, and we can make sure that let's say non-controlled sources and then demand side can be matched.
This is thank you, Zoltan. This is great also perspective to the topic. So questions are still popping up, so we'll address them. We will continue with you, Robert Tozer. Thank you for these great questions. So we'll bring the question on the screen. Which district heating scheme, generation 4 or 5, is more likely to be implemented with data centers in the future? And to answer that, I would like to start with you, Jeroen.
I'm not so well educated in the heat reuse system
Oh.
of in the generation 4 or 5.
Then maybe Drew, maybe?
Sure. Yeah, actually, I was very interested in this question,
Yeah.
and thank you for it. I think it's Dr. Tojic, but um, from the Danfoss opinion side, we think that a fourth generation district heating system makes the most sense when you have a primarily heat loaded application. If you're in an environment such as the northern part of Denmark where your primary load is going to be heat, then a fourth generation system seems to make the most sense from our perspective. And with data center heat recovery, what you're trying to do is, of course, the increased you're increasing the source temperature as opposed to other sources that you could use, whether it's groundwater or ambient air, or you're increasing the sources because as over the last 10 years, data center cooling temperature has gone up about 10K, over the last 20 years, about 15 to 25K. And so that in turn creates a temperature that you're recovering at. A fifth generation district heating system, just kind of as a baseline also for the people less familiar with it, it lowers down the distribution temperatures of that district energy system. And that is optimal from our standpoint, from a cost and from an CapEx cost and an operating cost standpoint, if you have a good balance of heating and cooling load. And so for a data center application, coming back to that in the fourth generation, because you're increasing what would be that distribution temperature, which you would then boost up in a fourth generation at a central location, that seems to make the most sense for a data center application. Whereas for a groundwater application where you're lowering down that distribution temperature, that would make the most sense for a good balance of heating and cooling loads.
Thank you. So I hope we've answered your question. Sorry, in the chat, Robert. So I would like to bring the panelists to one of the overarching questions that we discussed and that I would like to have your input on. The three of you are based in different countries. So looking at location and heat reuse, what are basically the current business regulation or the current transition that is happening in your country regarding heat reuse? And I would like to bring Jeroen.
All right. Yeah. So at the moment, there is not too much regulation in the Netherlands about what to do with waste heat, except for Amsterdam. I think already started, to question building new data center plans. Like, what are you going to do with it? What are your plans with it? So in the Netherlands, there are no plans at the moment, but I do feel that we are a big hub, and that of course has drawn the attention of the policymakers as well. So I really believe that within the next 5 years, we're going to see that the government will state that yes, you can build a data center here under the circumstance that you deliver the waste heat or the useful heat to a heating system, to a district heating or an industrial partner, whatnot.
Thank you. That's obvious. Yeah, that is changing, and what we've seen earlier is that it's changing slowly. And basically, I would like now to bring the point of view of Zoltan and Hungary, and how in your country, in the location, things are going.
From a regulation perspective, I know that there are some initiatives and there are some groups who started to work on different penalty systems if you are having too much waste heat. And I believe that's a good way to go, because then you are basically motivated to find a source for your waste heat. On the other hand, we've seen some projects where large data center operators and owners try to find the right place for their waste heat. But usually it's quite hard, because if we are talking about connecting the data center to a district heating network, as I mentioned, the most waste heat is produced during the summer, where the need is quite low. So we need to focus on the industry, and usually that's quite hard to connect two mission critical equipments. The one is the data center, and the other one is the industrial player, like food industry, chemical industry, or pharma type industry, where the manufacturing and the production is also mission critical, and the dependencies are usually too high, and they tend to build their own systems because they prefer this method. So I believe that the mindset also should be changed, and the focus should be taken on somehow motivating more the people and the operators to use this waste heat, because that's the cheapest source of heating, and that's the most efficient source for heating, and that's where we believe we can also support this transition by adding our thermal batteries in the middle, not just making the two systems more flexible, the connection more flexible, but on the other hand, adding a safety layer. So in case anything happens with one of the mission critical equipments or sides of the story, then there will be basically a balance element between the two players.
Thank you. That was a great point. What about you, Drew? When we talk about finding the right place for excess heat, what is happening in Norway?
I can speak less to Norway, but I can speak to Denmark very well.
Denmark, sorry. Yes.
No,
Sorry.
that's okay. That's okay. So the best place for the heat reuse from our side, from our perspective, is in a district energy system, and that's where you see the most movement, of course, is in Denmark on it, both with the existing district energy system infrastructure as well as expansion plans. There's a lot going on in other regions as well, in the UK and Germany and Netherlands, and even in North. But experience about it is, we were just at an application, one of the first applications with
This is the perks of being live and having some issue with the internet. So, yeah, we lost Drew. This is okay. Nothing is perfect, even the LinkedIn live as well, and this is part of this. Okay, so we will let Drew come back. We discussed also, you bring a very interesting point earlier, Zoltan, about critical facility. What is your perspective, Jeroen, on this critical facility? Because you deliver heat to data centers. So what do you see? What kind of advantage you are observing?
Well, I think for like the data center, it shouldn't be an added benefit. It should be a core value, at least that's block heating. And I think for like when we're looking at different industries, we specifically chose an industry, greenhouses, that also has a high heat demand in the summer. So yeah, otherwise, what are you going to do with the heat in the summer? So in that sense, an industrial partner was useful for us. And we selected a location where heat storage was already available. And basically, last but not least, and I think the most important one is make sure that we had a location which had all the facilities to operate on its own. So they are not really dependent on us, like we are at a benefit, but we should be able to decouple the two systems in case of an emergency. Like, for example, they don't need heat and we have a lot of heat, yeah, then we should have a backup system. So I think that, yeah, for us, that was a major deal point.
And for you, Zoltan, what's your take on this? Looking at location, the core values, what do you enable at heat venters?
Basically, if we are talking about this topic, so how to connect to facility a data center and another, let's call it industrial player, because greenhouse is another very good example. I believe there is one approach is to make it possible to break the connection very easily and to have redundant systems. On the other hand, I believe that's more economical to have a balance added to the system in a form of energy storage, because that way you don't need that much equipment, you don't need emergency equipment on any of the sides. Of course, it requires some trust, and maybe that's where we need to change a little bit, and that's where we need to work on making the connection very safe, making the demand and the supply part very solid, and somehow making the needs the same. So basically, providing the cooling need and providing the heating need at the same time. So we need those kind of industries where we can do this. In some cases, if it's about some manufacturing, where it is possible to have this flexibility as well in the manufacturing process, that can also help. On the other hand, it's possible to also add this flexibility for different data centers, or at least part of the computation or the IT load can be flexible.
Great, thank you. And as you just finished, Drew is back. So yes, welcome back.
Sorry about that. I have no idea what happened. All of a sudden, I was just cut off, and I was talking, so I have no idea where it cut off either. The point I was
yeah.
the point I was making was on the electricity price fluctuations. Did that come across before I got cut off?
Please, yes.
Okay. So the electricity price is highly fluctuating here in Denmark right now. And this is highlighting how critical it is to have the most highest temperature and most consistent heat recovery applications, and specifically data centers. And I saw the comments earlier that heating provided by data centers is not a low-cost solution. From the utility perspective, it is. And a good example of that was one of our first installations here in Denmark was on an application that's operating at heat recovery temperatures almost the exact same as a data center, around 30 degrees C, where data centers are being designed today. And the heat supplied to the district heating is at about a 70 C. And our efficiency with that application is about an 8 COP. As opposed to that, 7 to 8, depending on the source temperature. But as opposed to that, there's also a very large air-to-water heat pump system on site that is operating at about a 3 to 3.5 COP. So what that means is, and what they found out based on these electricity price fluctuations, is that it makes sense to operate that centralized air-to-water heat pump plant based on that efficiency only when the electricity price is below 600 DKK per megawatt hour, or about roughly 100 euro per megawatt hour. And as opposed to that, with our system and the higher recovered temperature, which is roughly in line with what you get from a data center where they're designing them now, it's 1,200. So double the electricity price, it makes sense to operate this heat recovery heat pump system, which is basically the same as what you would get from a data center. So when people say that it's not the cheapest source of heat from a utility provider's standpoint, it is. It is the base load, and that has become his base load for this district heating utility as a result. So, just as an example, I wanted to give.
This is great, and you actually said the word that would be my next question. So we will stay on this. So, how important do you think is the role of the energy utility in this transition? And I would like to bring Zoltan first.
Well, I believe it's quite important because, as we already mentioned and as we already discussed, a data center have a different business model. So basically, it's not their business model to provide the heat as a service. So we need a utility or any other company who will do this role. It's very important who is operating the equipment, who is providing all the different services to this level. But basically, I believe the role of the utility is very important. We need a middleman to solve some of the issues which is not connected to any business models.
And Jeroen, what is your view on the role of the energy utility as well?
Yeah, I think they could play a major role, especially if you're looking to the existing areas, existing data centers, existing heat grids. In my opinion, that's not fast enough, and that's really difficult to match all the temperatures without a heat pump. Like that was for us a major deal breaker in the design. So we said we go to the heat user directly. We have a direct net, and that's so in the general discussion, I think it's good to have heating grids, but we do have to take into account the CO2 emissions that are used to provide this heat, I think.
Thank you. And what about you, Drew?
So, based on what I was saying earlier, I obviously agree that the utilities play a critical role. In fact, we found that trying to get you can bang your head against the wall trying to get the data centers to change their business model to selling heat. It's much better to focus, especially where you have district heating, to focus on the utilities and them facilitating and recovering the heat and selling the cooling or providing the cooling to the data center. It seems to be a better business model. So they are an absolutely critical role in that.
Jeroen, you said that it's not going fast enough. And during our discussion also before, there was some points around business as usual. There are a lot of complication. What are still the barriers in this? Why is it not the norm already? Basically,
Well,
yeah.
I think we touched upon this point a little bit, but like in our opinion, high temperatures are the norm. And if you want to integrate on that, you have to deliver high temperatures. And that is fairly easy possible. Like your CPUs are still running at 80, 70 degrees in a typical data center. So then you might as well go for direct chip cooling or immersion cooling. And that allows us to get higher temperatures without an extra power use. And it makes the waste heat so much easier to implement in other systems. As mentioned before, like heating grids are at around 70 degrees. Well, that's really difficult to reach, I think. But 60 degrees, which is already onto standard in the Netherlands, at least health and safety wise as well, is doable. It's very well reachable, basically.
That's clear. Any input, Zoltan, on this?
Well, as a barrier, I believe temperature is a big problem. Flexibility is another big problem. We've seen some examples for successful pilots or for successful using the waste heat, but the problem is that the transition is not fast enough. I mean, we need to see the other side of the equation. So many times it's not economic, or there are some additional challenges which can occur when we try to connect two systems and when we try to force them to work together. From a utility point of view or from a district heating point of view, the security of supply is also an interesting topic, and that's true that data centers operate on a quite flat rate considering the IT load, but the heat generation, the excess heat generation, is not that flat. So it's quite complicated to calculate with this one, and it's quite complicated to use 100% of the excess heat. But that would be the focus to do projects where most of the excess heat or waste heat is used.
That's a good point, and I will stay on this because this is also one question in the chat. So we will bring the question from Nick de Jong. So I will state it, but it will also appear on the screen. At Leaf Cloud, we are that's not this. Yeah, we are convinced that transporting heat never has a positive business case. So waste heat should be reused directly, either to district heating or heat a building. Do you agree? Do you see any successful examples? And as Zoltan, you were speaking about it, I would like to put you first.
Well, I believe, I've seen many calculations for this topic. For example, in Hungary, we have a nuclear power plant around 100 kilometers from the capital. And I've seen many calculations what would be do with the heat, or how would be transported to Budapest to provide the district heating needs, to cover these needs. And yes, the business case was not very feasible in most of the calculations. So I agree that the heat should be used in place directly. So that should be a focus. But I believe to achieve this goal, we either need a utility who can make it happen, or we need companies who work together and own a data center and own a facility, a manufacturing facility, which can be connected.
Thank you. Great. Drew, any take on this question as well?
I'm a little bit confused by the question when you talk about transporting heat, because using heat in a district energy system is transporting heat. But I guess to answer the latter part of the question, I do agree that it definitely makes sense to use in district heating or heat a building. The key from our perspective is to be able to use 100% of the heat 100% of the time. As Zoltan mentioned, even from a data center, it's not consistent. But as opposed to the other potential sources, critical facilities in general, whether they're a data center, an industrial process, or a hospital, all of those applications have by far the most consistent heat capacity and temperatures, as opposed to the other potential sources that a district energy system or an individual building can use. So absolutely, that is the right path from our perspective.
Great, thank you. So, um, the three of you, you mentioned you mentioned some data center, hospital, basically the heat consuming industries. Do you see other industries that is consuming as well a lot of heat and that we need to take into account in the business model? And yeah, any maybe Jeroen, you have a comment?
Yeah, like we already mentioned, we are operating at a greenhouse. That only works, of course, in the Netherlands because, in the Netherlands we have a lot of greenhouses. I think if you look a bit further than that, there are a lot of industries that require a constant heat demand, basically, or at least constant over day-to-day basis. Like you might need a little buffer tank on site. But for example, even the food industry, if you want to pasteurize something, then I think with 63 degrees, you can already start a pasteurizing process. So that is almost achievable with the right technology, or basically it is reachable with the right technology.
And do you see similar industrial application in Hungary, Zoltan?
Yes, and I would like to start for at the food industry because so we've seen a lot of systems where the food industry is based on water, even from a tap water point of view, or they have a well on board, and usually the first task is they need to heat this water. Let's say they have a 10 degree water. If you have 30, 40, or even 60 degrees waste heat, then you can use it to preheat this water. I would say that in some cases they have a quite huge need, so megawatts of needs of only heating the water for different processes. For example, beer brewing, when they cook different foods, vegetables, meat, or any kind of substance in this case. So we see very good points and application opportunities for this topic.
Any complementing on what Jeroen and Zoltan just mentioned? Do you have any additional comment, Drew?
No, I think they covered it well.
Perfect. Okay, we can perhaps take some question from the chat. Okay, I need to have a look.
One comment I would like to make, if I can,
Yeah.
Julie.
Oh, please,
I've
yes.
seen several comments on PUE. As long as PUE is even in discussion in data centers, you will not reuse the heat. I just want to make that point. PUE does not take into account heat reuse. Right? There is no measurement impact. You have the exact same PUE if you're reusing the heat as if you're not reusing the heat, assuming you're not increasing the vapor compression cycle to reject the heat at a higher temperature for the heat reuse. That's the only impact into PUE that you would have in that. So as long as the people who are most interested in the topic are still talking about PUE, we will never change this industry.
That is a very good statement. Any compliment, Jeroen?
Yeah, I think it's completely correct. Like we should look further than just PUE. I would prefer like a metric of CO2 emissions per kilowatt IT load. I mean, or basically even go further, CO2 per calculation job. Like there are a lot of ways to reduce the PUE that will really harm the ability to recycle the waste heat, for example, water evaporation.
Yeah, that's a great point. What about you, Zoltan, on PUE and heat
I
reuse?
think I think the topic is complete. So I agree with the guys.
Great. And Ronald, hi Ronald, nice to have you. Also, yeah, great statement. So that's true. I mean, in this industry, it's been said that years that we need to go beyond PUE. So it's good to see that you also share this point of view. Okay, I will have a look at in the chat as well. So, for example, oh yeah, David. I think that's an interesting question that you just asked. So we'll bring the latest question from David. Yeah. Do you think that the price increasing of fossil fuels for heating will be the driver for combined heat compute? Very good one. Who wants to start?
I will go first. I think it's definitely true. Like what we already see at the greenhouse that we're at is that they are way more focused on the cost of their heating need now than like a month before. So I think this, like with our current transitions, we're only going to see higher peaks and deeper valleys in energy prices as well in electricity and in heat. And I think that will only be a driver for more waste recycling. And I think that's in that sense, I'm really happy with this.
That's good to know. And what about you, Zoltan?
Well, I believe the same. So by having to pay more for heating, cooling, or electricity, it drives and all kind of efficiency measures. So efficiency becomes more important, and I think it is a good driver because all of the business models are based on costs. I mean, there is a cost point of view. If the cost is increasing, then you need to do something to avoid the risk. You can increase the price of your service, but if your competitors try to find another way how to stay at a low price for the service, then you are losing the market. So it motivates everyone to invest in energy efficiency. And I think that's the future. So we need to do something.
I think this is a great statement. And what about you, Drew? Do you have additional comment on what Jeroen and Zoltan just said?
No, once again, I think they covered it really well.
Perfect. So it's all about motivation, changing the industry, looking at the future, more regulation, and making sure that that we all come together. And this was indeed a great question because David is actually the lead of our steering group on excess heat, so he knows exactly what we are discussing. Okay, there is time for one last question, and then we'll wrap it up. The question about sorry, the small percentage of data center, if we can put this one up. Where is it? I can't find it. Oh yeah. Zoltan, yeah, if you want to speak about it.
Of course, of course. Yes, I've seen in the chat the conversation about the small percentage of data centers compared to the overall energy usage. But I believe data centers are quite an advanced buildings. Operating a data center requires quite advanced knowledge, so they are very good and very well systems, and I think it can be a good start for saving the waste heat and trying to find solutions For data centers, for example, you need to provide uptime. So basically, this ensures somehow the continuity of the waste heat supply. So I believe this is a good starting point, and then we can move on the next industrial segments as well to identify similar opportunities to try to save the most waste heat as possible. So I would like to say start with the data centers, find the right solutions, and then we can bring it to other technologies.
Jeroen, I think this is also a topic for you as you are using data center heat. What's your view on this?
Yeah, like I think it's great that more companies are working on it. I think there's a lot to be gained. I think in the chat were two projects mentioned, and that's then running on a heat pump cycle. Yeah, in my opinion, that's like not the technical most optimal solution, but I think in the transitioning period that is necessary, and I think for the future we should really like engage not only data center but also data center users to think about a different way of cooling that allows heat reuse to be a bit more bit easier.
Yeah, agree. And you, Drew, what's your view?
Yeah, just to continue on that thought. I mean, the whole transition is from cooling and heating to moving heat. Both cooling and heating are moving heat, and we're trying to transition the data centers to looking at it that way. Once you transition the data centers business to looking at it that way, then it's the heat reuse becomes a no-brainer.
Great. Being mindful of the time, we are going to wrap it up. I think we could have stayed for a longer time. Also, the audience, because we have so many questions, so many statements. So it's been really refreshing to have the three of you on this panel. Great discussion. We had amazing feedback and statements. So thank you very much for your time. It has been very engaging and quite high level. So thank you to the audience as well. This has been a real pleasure to have your questions. So this is great. And yeah, I would like to thank you, Zoltan, Drew, and Jeroen for participating and taking the time on this panel. And we have a little tradition now when we end a LinkedIn Live, we would like to have a recommendation on, to give a recommendation of a book or an article or something that our audience can read. It can be also a podcast, something that that you would recommend for everyone to read. So, Drew, I will put you on the spot.
On climate change specifically, or just in general?
Anything. It can be a summer book. It can be a magazine. Something that
My
you.
favorite book of all time is Cormac McCarthy's Blood Meridian. But the climate change, the long emergency is still my favorite because it came out like 20 years ago and it's just spot on.
Very nice. What about you, Jeroen?
I don't know if there's a English translation of the book, but it's from Michiel Muller. Entrepreneurship is an ABC. It's basically explaining that from your initial starting point A, you might not be able to see business model C, but as soon as you move from A to B, then from B you could maybe see it. And that's basically also what I think is happening now within the data centers. Like as soon as you move into more efficient cooling, waste heat recycling, then you can finally see the other cases on the other side.
Nice, thank you. And you, Zoltan?
Well, usually in my free time, I try to get motivation from others' sides of, let's call it life. So basically, I'm not reading a lot of technical books because I'm doing it every day in my job. So when in the weekend I have some spare time, I usually enjoy some fantasy books. And what else can I recommend? Lord of the Rings. So
Yes. Yeah, yeah, likewise. Nice. And so, last words, if for the audience watching, we have the steering group on excess heat utilization from data centers. If you are a member, please reach out to us and we will sign up for the next session. And if you are not a member, still reach out to us because we are assembling all actors in the sustainable digital infrastructure, and we need everyone from across the value chain. So with this, thank you again, the three of you, Zoltan, Drew, and Jeroen, for the time to be with me today discussing these topics. Thank you for the wonderful audience. Thank you for the question. And that is the end of our LinkedIn Live. See you at the next one.
See you.
Thanks.
Bye bye. Thank
bye
you.
bye. Have a nice day.